So the second method we're going to use is actually the method that's preferred by many students because it's maybe a bit easier, and in the textbook you'll find it's a bit used more often. So let's go through that and see how that works. Remember, the two methods are not really different. They're just different in the sense that you have to follow different steps, but in the end you're doing the same thing. So first you get the magnitude of the force only. You don't worry about the sign at all. Then you put the direction of the force on the drawing by hand, knowing that like charges repel and unlike charges attract. And then you put the components yourself. You have to make sure that the correct sign is done yourself. So this depends a lot on making a nice drawing, a nice big drawing where you can resolve things and put things very clearly. So that's maybe a bit easier to use sometimes. Let's go through and see the problem. Exactly the same problem as the previous one, but now we'll solve it with this method. So the first thing we said we're going to ask for is the magnitude of the force on 3 due to 2. I don't care about signs. I just want a number, a positive number, the magnitude. And of course, we know the magnitude of the force between two charges is Ke times the magnitude of the first, magnitude of the second over the distance squared. So it's very easy to get the magnitude. And then the next step is you put the force vector yourself on the drawing. You know there's a charge here, there's a charge here, they're along the same horizontal line. So how would you put the force on 3 due to 2 yourself? You know that opposite charges attract, so the force should be left. So yourself, you put this, that the force on 3 due to 2 is pointing to the left. Then you determine the x and y components of this force vector yourself from the drawing. Now you see there's no y component, so F2 on 3 due to 2 in the y component is 0, is going to be 0. And what about the x component? The x component is, you have to put the minus sign yourself. The force is pointing to the left, so you have to put the minus sign yourself. So the minus sign, this minus sign, you have to put it by hand. You can't assume that it's going to come automatically like in the previous method. So you put the minus sign yourself, you put the magnitude, and then you forced now the force to be in the negative direction for the x direction, for the x force component. The y component is 0. So this is what the case for the force on 3 due to 2. We got its x component and its y component. Now what about the force on 3 due to 1? Remember again, first focus on the magnitude only. Forget about any directions or signs or anything. So the magnitude, of course, as usual, it's Ke times the magnitude of the first, magnitude of the second, divided by the distance squared. The distance is the root 2 of a, so it's root 2a all squared. So this is the magnitude. Then put the force vector yourself on the drawing. These two charges are like charges, so they should repel. So I know that the direction should be this way. So put the vector yourself on the drawing, pointing in the correct direction. And then determine the x and y components from the drawing. So I want to get the x component and I want to get the y component of this vector, which I know its magnitude. I know the magnitude of it, but I want to get its components. So I'll just put a kind of a local x and y axis like this, and you can identify that the angle here is 45 degrees, the angle here is 45 degrees. So I have a vector that I know its magnitude and I know the angles, and I just want to get the components. So it's a very simple problem of getting components of a vector. So you put the magnitude, multiply by cosine 45 to get the x component, and you put the positive sign yourself by hand because you know it's going to be in the positive direction. For the y component, you get the magnitude, you multiply by sine 45, and then you put the positive sign yourself by hand. So now we got the force on 3 due to 1. And now, if you want the x component of the total force on 3, well, remember, if you want to get the total force, you have to add the x components together. So I have to add the x components of the forces on 3 due to 1 and on 3 due to 2. This is the force on 3 due to 1, the x component. This is the force on 3 due to 2, the x component. You just add them. When you add these two, you substitute the values, you get minus 1.1 newtons. Then for the y component, we have one of them is 0 and one of them has this value. You add them and you get positive 7.9 newtons. get exactly the same result, of course, as you should, but the issue is that the steps that you follow are a bit different. In the end, you're going to have to resolve, I mean, maybe some people think that getting the unit vector is more difficult, but in the end, you're going to actually have to do the same thing to resolve the force vector. So you either resolve the unit vector or you resolve the force vector. It's the same thing in the end, but the steps are a bit different. So you have to have a strategy going into solving a problem. Either solve it the first method or the second method. You choose which one ever you feel is more convenient. So to summarize, the force on 3 due to both charges is the force on 3, the x component in the I direction, plus the force on 3, the y component in the j direction. And to get the x component, you get the x component of the force on 3 due to 1 and 2, you add them. To get the y component, you add the y components due to 1 and due to 2 on 3. And so you get exactly the same answer as before.